Hello everyone, we've now got up to question 11 in this paper 3. So it says Freya writes down the value x correct to one decimal place. She writes down 6.4. So it says complete the error interval for x. So we just need to write down the upper and lower bound. So we're going to write 6.45 for our upper bound and 6.35 for our lower bound. So that's all there is to that one. Question 12. Ax to the 6 to the power of 1 over n equals 7x cubed. Work out the value of a and the value of n. So, first of all, let's think about another way to write ax to the 6 to the power of 1 over n. Using this law of indices, ab to the n is a to the n, b to the n. This means that a, x to the 6 to the 1 over n, is the same as a to the 1 over n to the power times by x to the 6 to the 1 over n. So that's just breaking it down using that law of indices. And then we can further simplify this expression by using a to the power of n to the power of m is equal to a to the power of n times m. So when you have a power to a power, it becomes a product. So that means this is going to be 6 times by 1 over n, which is 6 over n. Okay. Now, once we've got to that stage, we can compare directly the x's. So we know that x to the 6 over n must be the same as x cubed. So we can equate the powers. We can say 6 over n is 3. So 6 over n is 3. So that means that we swap those two over. And that means that n is 6 divided by 3, so n is 2. Now we can compare the a terms. Okay, so we've got something to the 1 over n equals 7. So something to the 1 over n equals 7. But that n is 2, we found out just a moment ago. So that means that a to the half is 7. But remember, a half means square root. So the square root of a is 7. So we square both sides. So a is 49. And that's the answer for that one. I know people find those indices questions quite tricky. Now, here's another question that people find quite tricky, in my experience, especially when I've looked at this one in the past. People just get a little bit flummoxed about knowing how to start this one. So there's the a mark scheme there for us on the left, but it says a pattern is made from 4 identical rectangles. The sides of the rectangles are parallel to the axes, which is good. The point A has coordinates 3, 4. The point B has coordinates 11, 20. And the point C is marked on the diagram. There we go. Work out the coordinates of the point C. So as a way of breaking this down, I've imagined that going along the X, I've called A, and going up the Y there, I've just called B. So if I was going to go from A to B, let's write an expression for that. Well, I would have one lot of A would get me from there to there. Another lot of A would get me from there to there. But I've got to go back in by one lot of B. So the expression to go from there to there is 2a minus b. Okay, so 2a minus b. So that's it in terms of the algebra. Now, we know that the x-coordinate of b is 11 and the x-coordinate of a is 3. So that means that that must correspond to 8 in the x. So going 2 a's and then 1 b in is equal to 8. So we make a note of that. We formed one equation there. Now let's have a look at the next thing. Let's do the same thing with the y's, okay? I need to go up 1b. I need to go up 1a. I need to go up another a. So 2a add b is how we go from the y value of 4 there to a y value of 20 there. So that means 20 take away 4 is 16. So that means 2 lots of a add b must equal 16, okay? And then we can just solve those two simultaneously, okay? Here, I've solved them by rearranging to make, what have I made the subject? B the subject, and then subbed in and solved, okay? Which gives us A is 6 and B is 4. Or, as an alternative, you could just add those two equations together, which would also be fine. But in essence, we're just solving a pair of simultaneous equations. So I could have, if I wanted to, add those two equations together, which would have given me 4a is equal to 24, which would have given me a is therefore equal to 6. And then from there, I could have worked out that b was 4. So that's an alternative approach. You could just add the equations together. Now, once you know what the value of A and B is, then now we've not quite finished yet. We've got to work out what C is, okay? So how are we going to get across to C? Well, to get across to C from this x coordinate of 3, I need to do 1A. So the x coordinate is going to be 3 add A. And we know that A is 6, so it's going to be 3 add 6, so it's going to be 9. Let's now look at the y coordinate of C. Well, it's just going to be one lot of B. So it's going to be 4 add B, because we just said 4 and we go up by B. And we know that B is 4, so it's going to be 4 add 4, so it's 8. So the coordinates of the point C are 9, 8. Quite a nice little question, that one. Oh my goodness, this one. Now you can see from the amount of scribbling out here that I really didn't enjoy this question the first time I did it. And yeah, to be fair, to be honest, it's like I do find these kind of questions in GCSE really quite tricky. Definitely prefer A-level papers to this sort of maths. So let's have a look at it, see what's going on in this, what I thought was quite a confusing question. Although I remember with my year 11 group, when I did this back in the day, they had a really neat way of doing it, and they basically like solved it in no time whatsoever. Okay, let's have a look. So it says Olivia and Jessica have in total half as many sweets as Fran and Gary have in total. So let's think about that first of all. So here we have Olivia and Jessica. So the amount of sweets they've got is half the amount of sweets that Fran and Gary have got. Okay, so that means a ratio of 1 to 2. Okay, fair enough. That seems all right, doesn't it? Now, Fran and Gary, they share their sweets in the ratio 2 to 3. Okay, so that's fine. So Fran and Gary share them in the ratio of 2 to 3. So I've just divided it into 2 parts. Fran gets 2 parts, Gary gets 3 parts of their share. Okay. Olivia and Jessica, they share their sweets in the ratio 9 to 1. Wow. Okay, Olivia's getting a lot more sweets. So basically, this one portion gets shared in 9 to 1. And this bar method of doing it is like makes it like so much easier, in my opinion. So now let's have a think about this. Okay, so now we've got to think about where we're going to go from here now. So if we assume, let's assume that Olivia and Jessica had 10 sweets that they were sharing between them, and that Olivia had 9 of them and Jessica had 1. Okay, that just makes life easy because it doesn't matter what multiple we have because we're just aiming for the ratios. Okay, so if we just imagine, for the sake of convenience, that Olivia had 9 and Jessica had 1. Well, that means that if they had 10 sweets altogether, then that means that Fran and Gary must have had 20 because it's the ratio 1 to 2. Okay, so that's fine. So in order to work out if it was the case that Fran and Gary had 20 sweets shared between them, then we just need to divide 20 in the ratio 2 to 3. So we say 2 add 3 is 5. 20 divided by 5 is 4. Every one part of that ratio stands for 4. So 2 times 4 gives us 8. So Fran had 8 sweets. And 3 times 4 is 12. So Gary would have had 12. So if Fran and Gary were sharing 20 sweets between them in the ratio 2 to 3, that means that Fran would have got 8 and Gary would have got 12. And this works out fine because it doesn't matter that we assume that they had 10 sweets there, because if we needed to, we can always cancel that ratio down. Okay, so we've now got this little fraction bar here giving us all of the ratios. We don't actually need all this working out what I've done down here. This is by far I think the most convenient way to look at this question. But we've got to be careful because the question asks us, we've got to work out the ratio of W to X to Y to Z. So that is the ratio of Fran to X, which is Gary, to Y, which is Olivia, to Z, which is Jessica. So be careful because that's not the order they're given in the question. So we've got to do Fran first. So Fran had 8. Then we've got to do Gary. Gary had 12 parts. Then we've got to do Olivia. Olivia had 9 parts. And finally, Jessica. Jessica had 1 part. Okay, so just be careful about the order in which you write them down. And that's perfectly fine to write that as 8 to 12 to 9 to 1 because it can't cancel down. There's no common factor there. So that is, I think, the superior way to approach that question, which, as I say, I found really confusing when I first saw that question. What's next here? Okay, so this next one, it says, the graph gives the volume of water in liters in a container t seconds after the water started to flow out of the container. Okay. And it says, using the graph, work out an estimate for the rate. There's the key word, rate, at which the water is flowing out. You must show you're working. So we're looking for a rate, which means liters per second. In other words, it's the gradient that we need of this graph. Okay. So we need to find the gradient at the point where t is equal to 12. So when t is equal to 12, let's think about this. T is going to be here. So we're drawing a tangent to the curve at that point there, okay, where t is 12 there, you see. Okay, so we draw a tangent and we just work out the gradient, like the rise over run, so y over x. So the y is 29, the x is 29, so I've got that the water is flowing out at a rate of 1 litre per second. I think they'll accept in the mark scheme answers in the range from 0.7 to, in fact, 1.1, I think it said in the official mark scheme. All right, that's that question done. Let's see what's going on with question 16. Oh, now this is interesting. Okay, this is quite a very, very interesting point. I should be very interested to see. There's lots of approaches for this one. The curve C has the equation x squared add 3x minus 3, and the line has the equation y minus 5x add 4 equals 0. Unusual way of writing that line. Show algebraically that C and L have exactly 1 point in common. Okay. Now, there are a number of ways of doing this. So what we're going to do is we're going to put them equal to each other, and we're going to see how many times they intersect. So we're going to see how many solutions we get, because curves equal each other where they cross over. Okay, so we put them equal to each other and we're going to solve it. So having put them equal to each other, you take 5x off both sides. So that gives you minus 2x, because 3 take away 5 is minus 2. And then you have minus 3, but you're going to add 4 over, so that gives you plus 1. So we end up with the equation x squared minus 2x add 1. Now that factorizes into x minus 1 times x minus 1, which is a bit of a sneaky thing to spot. So that's x minus 1 all squared. So that means there is only one solution, okay? And that comes from x is equal to 1, okay? A very much more advanced idea of doing it, which is more of an A-level idea, is when you sub two equations equal to each other and you get a quadratic, if you work out this b squared minus 4ac part of the expression, and this has a special name, it's called the discriminant. Okay, there it is, discriminant. If that is greater than 0, it means the curve and the line intersect at 2 points. If it equals 0, it means the line is a tangent to the curve. And if it's less than 0, it means that the line misses the curve altogether. So what we do is you put the line and the curve equal to each other and you get a quadratic, this one here. And there it is, you see, x squared minus 2x add 1, x squared minus 2x add 1. You then evaluate the b squared minus 4ac. That's the b, the minus 2, the a is 1, and the c is 1. So we have minus 2 squared minus 4 times 1 times 1, which is 4 minus 4, which is 0. So because that equals 0, we can say, therefore, the line is a tangent to the curve and only intersects once, because we have this second scenario here. But that is a much more advanced idea, although it's technically, I have seen GCSE exam questions where they've asked you to prove that a line is a tangent to a curve without solving it. And the way they did it was using this technique. So it's very often not taught at GCSE, but technically they do occasionally ask using this approach. So it's very much an A-level kind of approach, but it's good to know, I think, just in case they do that thing where they ask you to use that approach. Okay, but I have seen it before. Okay, that's good. I think I will leave that for there, and we'll go look at this next question in the next video.